Hello, good morning, and welcome to the manufacturing spotlight session. Uh, if you could just, the gentleman at the door, if you could just get the doors closed in for a little lesser noise. And again, a very hearty welcome to, we saw a great start of the day with the FTC being inaugurated by a very eminent panel. We will dive straight into the first block for manufacturing. Now, to set the context of what we are expecting, and I know manufacturing is as vast as the mark of the human civilization. How do people mark how men or women progressed over a period of time is by seeing their tools, seeing what they produced, because those are the testimonies of time. So I think it's in a very great position today to say that possibly we are at the breakthrough of we are living the fourth industrial revolution. We are possibly in the breakthrough of the fifth industrial revolution. And we will see that and hear that through the snippets of the various companies and the speakers who would be coming and talking over here. Please line up your questions, because your questions will be very important if it's not on the topic, we will still try to answer your questions if they're interesting. Otherwise, there will be other ways of reaching it back to you. So just to set the stage right, we will try to touch topics, and I'm going to just kind of narrate out the topics. I'm not going to elaborate that, because that's kind of preaching to the choir. Some of the technologies that we will obviously be talking about and we'll hear a lot about is the Internet of Things and the industrial Internet of Things. What makes it industrial Internet of Things, other than the ruggedization of the sensors, would be the 5G and the edge computing that's coming to support the kind of data that would be generated and that needs to be processed at the edge. We will be listening to predictive maintenance as a fallout of that edge computing. We will listen to digital twins, both in the context of in the planning phase, as well as in the maintenance and the operations phase as maintained state of stuff. We will obviously be, I don't know whether we will have very deep discussions, but we will talk about some of the extended reality and the metaverse applications in the space of manufacturing, the dark factories, automation, leading to the dark factories, maybe the gorilla in the room kind of a question of what happened to the jobs, what's going to happen to the livelihoods. Will the Luddites win by saying the dark factories are anti-human? We will have a healthy debate, I hope. We will look at the robos and the cobos, very important, because I think the world will settle down with robos and a human working together on a supply chain or on a machine line. We will hear a little bit about 3D printing, more also in the context of the alternate materials that we will be lining up a full session on. Blockchain, NFTs, Web3, even from a perspective of product process certification and quality as it moves through the supply chain. And finally, the whole goal, the big gorilla in the room is sustainability. How does it all lead to more smarter and more sustainable products? So without much further ado, I would request, gentlemen, can you? So we have, I'm sorry, can you just give me the agenda, yeah. Do you have it on the screen, the agenda? Okay. So I'm going to speak out the agenda over here. So we will have Sanjay, Shanbhag from Siemens talking about innovation in the industry panel for the first setting the tone for the manufacturing session. And then we will have a panel which is on advanced materials and alternate materials, especially in the gamut and the scope of manufacturing, which will be between Suraj Ranganajan from Applied Materials and Suchishmita Sanyal from Shell, and I'll be moderating this session. And then we will get Shrita Dharmarajan from Hexagon Manufacturing to speak about quality that kind of binds the whole story together for manufacturing. That's the spotlight session, and then at the end, we would have the felicitation of the speakers. So all the speakers, please, after your session, stay back in the audience, hopefully that we have the chance of doing a combined felicitation. So with much further ado, I'll be calling upon Sanjay to come up and set the tone for this very august conference. Welcome, Sanjay.
Okay, smart manufacturing using digital twins. This is the topic that I'm going to be talking about today. So we've already had a lot of interaction between the physical world and the virtual world in the morning, right? So it's very, very interesting. So that makes my life easier. So looks like I don't have to talk a lot about digital twins. But let me talk about smart, right? What does the smart mean in our context today? So it means quite a few things, in smart manufacturing, but I will pick, say, the top three, right? The first one is about data. We get a lot of data from sensors, from controllers, from HMI, SCADA, and the information that we get out of this data and the smart decisions that we have to make using this is the first one. Second one is about modularity and flexibility, right? And how do you make your plant flexible and modular so that you are able to manufacture in a very, very flexible way? There is a right product mix that you are able to get. The third thing is about collaboration and communication between various entities. Can not just the robots, but can robots and cobots and human beings collaborate and manufacture? That's about smart. So let me start about how industries have evolved, right? I know this is the famous slide, we have spoken about it many times, but just a reminder about how industrial revolution took place and where we stand today and what are we looking into the future. The first one was about machines, and it was about mechanization. The second was about electrical machines. This is where we got the first car assembly line, right? You remember the Ford assembly line, Ford T model? You can buy any car, any colored car, so long as it's black. Then we started with using electronics and computers, and that's where robots came into being. And this is the Industrial Revolution 3.0. Today, we are actually in Industry 4.0 revolution, right? Here is where you had IoT, IIoT coming in. You had fiber physical systems. We had horizontal and vertical integration in terms of communication. And this is now leading into something called as the Industry 5.0. In Industry 5.0, the key thing is mass production using newer technologies, which is basically cyber physical systems or cyber cognitive systems, robots and things which are able to think on their own, and they are able to collaborate with human beings and bring about this keyword, right? Personalization is what I'm talking about. The customer really becomes the center of everything, and everything is individualized and personalized. Okay. So there are evolving industrial needs, right? So these are things that have evolved over a period of time. If you say smart, right? What was smart maybe 20 years back, 30 years back is very different. Today we are talking about not just these needs which are there, smart, your quality, personalized things, connected and profitability. You are talking about security and scalability. It's also connecting the dots, right? So what digitalization has given us is, we are able to look at all these needs in a much more holistic way, right? Can we just have some technologies, which are able to solve not just one of these needs, but many of them, right? So this is what digitalization is going to help us. But how digital twins can help solve this, right? Even before that, what is a digital twin? We are all, some of us are familiar with this, but just as an explanation, right? We are familiar with simulation and modeling, right? Mathematical modeling, where we are able to have attributes, use algorithms, use mathematical models to simulate what is happening in the real world. But when it comes to a digital twin, there is a continuous learning between these two worlds. There is a lot of data that you get from the real world. You are able to process it. It could be algorithms, it could be learning through machine learning, and then you are able to feed this back into the real world, right? So again, this loop continues, and that is how you are able to optimize your systems to the right levels. Okay, so this is what about digital twin. Now, where all can I use digital twins? It can be used pretty much throughout your manufacturing life cycle. It starts with your engineering design, real-time control or a production control. You can use it for operator training. You can use it for offline analytics, plant and health checkup, predictive maintenance and video surveillance. So, I mean, there are a lot of areas where you can actually use digital twins. So let's look at, in a typical discrete manufacturing plant, what is the role that digital twins can play, right? So it starts with, you can see the real world part here. It could be an automobile or it could be an aeroplane that is getting manufactured. There is a real world where the manufacturing is happening. And, in the next phase that you are able to see here, you're between the product design phase and the manufacturing phase, there is also the overlap, which is the product planning phase. In all these places, you are able to see that there is a corresponding digital world on the other side. Part manufacturing, you are able to actually visualize your parts, design it. You are able to virtually manufacture it. You are able to validate it even before you go into the production. If it comes to the production planning phase, you are able to do that in the virtual world, get the learnings to the real world and do a actual planning. Throughout the production cycle, you can have digital twins. If it comes to the digital services part, the industrial communication, motors, drives, motion control, all these aspects which come into play when you're actually manufacturing, you can have the virtual side. I was talking about, make things right the first time thanks to simulation and validation. Otherwise, how much of wastage is there, when you're trying to manufacture something before validating it in the virtual world, right? So there is a real product, there's a digital twin product. When it comes to the product design, there's a real production, and there is a digital twin production on the other side, on the virtual world. And there is a continuous learning loop between these two things. Let's look at, we spoke about, the Ford T model, probably the first assembly line for cars. You can always buy any colored car so long it's black. But today's automotive plants and the assembly line, the very next car that comes is very different from the one that is happening in the first one. It is not just the powertrain variants that you have. The color of the car, if you are willing to pay, you can choose shades of cars. You can order it online. You're talking about the color of the seats, the type of seats, the car heating. There are so many variants that people are today willing to order, and there are companies who are manufacturing it pretty much kind of a made-to-order thing that you need that kind of a flexibility. That's what we are talking about. So in the future, how would, maybe 5 years down the line, how would a typical car manufacturing plant look like? So we have, the electric cars and the international combustion cars, the IC cars, are being manufactured side by side. This is what we will have in the future, in the short future, I would say. You can see in the supply chain at the top, you're having the parts for the electric car, parts for the international combustion cars, coming together. There is a supply chain that needs to be highly optimized. Right in the center, we are talking about digital twins, right? Right in the center, you have a green digital twin. So how do I make my cars greener? How do I make my production greener? All those things, concepts can actually be covered in your digital twin at the center. Talking about digital twins, again, you've seen a couple of folks here, with the Google Lens, the HoloLenses, in the virtual reality world. There's a coach, and there's actually a virtual manufacturing that's actually happening here. You can bring this paperless virtual manufacturing, once things are fine, bring it to the real world. You're talking about quality management. You're talking about energy management to make it much more efficient. You're talking about speed and stability. We spoke about data. And there's a data coming in from various aspects of your plant, going into the data mining, going into the cloud, complexity management. This is how, even in the short future, I would say the typical car manufacturing plant would look like. Another example, right? We were talking about digital twin. Specific, personalized medicine, right? Can you have a digital copy or a digital twin of your customer, of a patient? You can. So the digital genomes that we are talking about. So here's the digital twin right at the center, right? If you're talking about very, very specific medication that needs to be manufactured for this person in terms of the weight, size, and all the parameters for an individual, you're able, you will be able to do it. So there are personal recipes based on allergies, tastes, etc. You can manufacture very specific medicines. I also spoke about modular manufacturing. So you see various modular and various batches of different kinds of medicine that can also be manufactured. So you need that flexibility and modularization in your plants. So 3D specific parts, we spoke about additive manufacturing, right? Prosthetics manufacturing, customized to an individual, right? It is ordered for this individual, you manufacture it, it gets shipped to you. Factory in a box, on the other side, we also, you might have heard about vaccine containers, right? These are containers where you actually manufacture, the manufacturing setup is in a container. You're able to ship that container to a specific place of consumption and, do it there. So factory in a box concept is also something very related. Digital twins can kind of help there. Again, there's a digital twin, right sitting at on the right side, where you're able to get data for, from the cloud. It is actually virtually manufactured in the cloud, and you can do a tick box on the right side, and you can send it to the actual physical manufacturing. So this is how personalization is answered through the digital twins. Cyber security and security is a very, very important aspect today also. Digital twins can also help you in a product security perspective. You can actually simulate attacks. You can actually do intrusion detection virtually and see how your system is able to behave. Today we are talking about data which is very, very specific to individuals, plus a lot of personal data. So product security becomes also a very important aspect. So let's talk about one specific example about prototype manufacturing. This is one of the Siemens products, Cinemeric 1. Before you actually manufacture prototypes, right? The earlier way used to be, you manufacture prototypes and see, whether it is meeting those tolerances, etc. And there is a lot of wastage. It is not just the product design I'm talking about, actually the manufacturing part. So there's a product design where you are able to do the CAD, and then you are able to actually manufacture, and you have to have the right part programs for your CNC controllers, as the parts are being manufactured. Right? Instead of doing it physically and, if you don't get the tolerances right, throwing it away, you are able to not only design your product, but actually do a virtual manufacturing using the part programs and see how the part actually comes out. Because many of these parts are very complex to manufacture. The contours, the tolerances that you have are very, very rigid in some of the applications. Here is where your digital twin and your manufacturing, virtual manufacturing comes into play, and you are able to do it with minimal wastage, right? Allow activities that lead to unproductive machine times to be consistently shifted to the CNC job preparation. And CNC job preparation and virtual manufacturing plays a very key part. We have systems in place in Siemens which can help you do that. We will also talk about a life cycle digital twin. So we spoke about one discrete manufacturing, in an automotive sector or an aerospace sector. But when it comes to manufacturing or setting up of a plant and then running it, it starts all the way, on your right side. If the conceptual and process design is there, then you do your basic front-end engineering and design feed. Then you have a very detailed engineering that you do. These are all, can be done in the virtual world. Then you actually start your construction and startup of the plant. You do operational and improvement, when the plant is kind of running, and then there are upgrades to the plant where you do a modernization. So in all these aspects surrounding, right, if you see, there are digital twins that can help you. There's a concept digital twin, there is a process digital twin, there is an apparatus design and a plant design twin. There is a commissioning twin during the virtual commissioning, there's a training twin, there's an APC, MPC, that advanced process control and model process control. Then you have the operational twin. Even sensors need not be, the hard sensor, they can be soft sensor, and you have the shadow plant. So in all this complete life cycle of a plant, setting, conceptualizing it, designing it, setting it up, commissioning it, and the running it and optimizing and upgrading it. In all the aspects, digital twins can play an important part, and we have products and systems in place to do this. So overall benefits of digital twin, planning, validation, and adjustment of the manufacturing process is one of them. You can have production scheduling assistance, dynamic risk management, validation of production sequence, validation of completed part or assembly. So there are many, this is just a pick of those, there are many advantages that you have by using digital twins. There are, okay, maybe this is not the latest slide set, but it's okay. We will see these two things in our booth. But before that, a couple of real examples of where we have used digital twins with our customers in Siemens. Okay. How about taking a picture of your head profile, sending it to this company, and they will 3D print and manufacture a bicycle helmet for you exactly that is fitting. It's no longer the t-shirt sizing, right? It is large or extra large or small or medium, right? It is exactly fitting to your head. So here is again where we have used our digital twin technology and 3D printing linked to the 3D printing, where we are actually able to help this bicycle helmet manufacturer to perfectly manufacture a helmet that is precisely fitting to your head. Another part, very complex prototype manufacturing, again, Numeric 1 is one of our products. Can we move some of the manufacturing tasks to the virtual world? Yes. Some very complex aerospace manufacturing, we have been able to help our customers to move this, do a shift left, do a virtual design, do a virtual manufacturing, and reduce a lot of cost in terms of bringing out prototypes. So productivity and sustainability, we spoke about sustainability quite a lot. Here is another example where we have leveraged a very comprehensive digital twin for a manufacturer of e-aeroplanes, electric aeroplanes. You see the benefit, 66% reduction in engineering effort, 7 days, we saved in the certification process. And how did you do it? Again, it's a very comprehensive digital twin leverage that we had. So what this industry is aiming at again is, how do we reduce the operation cost? How do we reduce the carbon footprint in the general aviation? So this is another very good example that we can showcase when it comes to using of digital twins in manufacturing. Manufacturing to make an electric plane which is more sustainable and having a greener manufacturing process. Both these have been addressed in this plant. Okay. So this is in short what I wanted to talk about today, and how digital twins are helping in various aspects of manufacturing, or in how do we make manufacturing smart using digital twins. Okay. Thank you.
So, is it on? Working? So for the time for questions for Sanjay, there are microphones over there, and if you have questions, but maybe Sanjay, maybe I'll ask you the first question to kind of trigger off. So we are seeing how digital twin, and you spoke about how the first time right has actually happened, and Siemens is a perfect example, being a manufacturer themselves, one of the world's largest leading manufacturer, and one of the world's largest leading software company in the manufacturing space. Maybe you can talk a little bit about a reconciliation of how Siemens has used its own technologies to achieve some path-breaking, groundbreaking achievements.
Absolutely.
And especially if it's an India example.
Yeah, so eat your own dog food, as they say, right?
Yes.
So Pankaj spoke about a very good example in the morning, right? How the Kalwa factory was optimized. So we have a huge manufacturing plant in Amberg in Germany, right? This is one of the places where we have pretty much used all our technologies, for manufacturing a lot of industrial automation equipment. I do not have the exact numbers, but the It's also showcased quite a lot in we bring our customers to see our own products live in terms of the digital twins also, and how it is helping optimize our own manufacturing processes. The numbers are quite stunning. We have improved, the productivity we have made, the product mix, very, very high product mix and low volume factories also in Fjords, I remember. How we have used your digital twins and planning, to make this happen. Yes, not just in one or two plants, but in many of our plants, we use our own, digital twin systems that are available, and we have achieved, tremendous improvements. Okay, there's one question. Okay.
Yes, Pranjal.
So you spoke about individualization, and I thought that's quite fascinating. But I'd like to understand, how do you manage the challenge when you have, let's say, the bike helmet? So it's not about 10 helmets. Unlike an aircraft, which is finite numbers, you could have 10 million bike helmets, and each of those heads would require specified shape or size. Mm-hmm. It could change with age. How does that work at scale? How do you ensure that you're getting individualization at a mass level? What are the cost and effort implications?
Yeah, so it's about 3D printing and additive manufacturing, right? So this is where exactly you're able to feed in right in time, and the 3D printing will manufacture to size. But the cost of 3D printing, is something that has, over a period of time, I also hear that it is coming down, and that is a crucial aspect of it. So if you are able to get down the 3D printing aspects, to a scale and size, where it's very manageable and affordable, I think that would be a big win. I see that happening, if this is a working story, right? So I would say that this is really the key element. Yeah.
How do these 10 million, let's say there are 10 million helmets to be made. Each of those 10 million helmets require a different size. You have to reach out to each of those customers have to get their head scanned, they have to send it to you, you have to print it somewhere and then reach it back to them. You can't walk into a shop and buy it the way people do right now. So I'm talking about the entire chain of activity, because it's not just about customizing and printing one helmet.
It's about
how do you do it for 10 million people, for 100 million people, different sizes, ages across the world?
Yeah, so it all starts from the ordering part, as you said, right? If you have an app which you can download from this company, scan it and send it out, you upload it, it goes to, one of their sites, and it goes into one of their data, it gets, positioned, then, it's kind of printed out, it's sent. So the 3D manufacturing scalability, is in my view, one of the key things that need to be solved in this entire chain. Rest of the things pretty much exist. I mean, photo printing online, right? And that's happening, to a huge scales. But where do you see the real bottleneck here? That's the reason I said it is the 3D manufacturing scaling that you're, even in, manufacturing today, right? Earlier it used to be, okay, I own a factory, let me manufacture everything today. But it is moving into a direction where, there are 3D manufacturing setups, very, very large manufacturing setups that are happening, and not just one manufacturer, who is intending to manufacture. Many people can outsource the manufacturing to this very large scale setting. So especially when it comes to 3D printing, it is kind of moving in that direction.
It's distributed.
It's distributed. It's not that sometimes it comes from one manufacturer, but whoever is able to give you the manufacturing space, right, in these 3D printing.
Another practical question, will the cost of logistics undermine the effort and the cost reduction of customization? Because then you're also shipping 10 million items. You're not going to a store and where there's collective warehousing and shipping happening.
Yeah, I know it's an interesting question that needs to be solved. What probably started off as on a smaller scale, when it scales up, there are different challenges that definitely do come in. But yes, the fact that individualization is a need of the hour, and it needs to be solved. But when more and more, such helmets or even this personalized medicine start getting manufactured, there will be other allied, challenges that would come in that needs to be solved. But in the digitalization era, and if you're talking all the way from the supply chain, you're talking about trusted traceability. If I go to the medicine, right, you're able to trace things using blockchain, from various parts of the world. That is one technology that is going to be helping you. If it comes to shipping and logistics, etc., today, Swiggy or food or something that is being shipped, you're able to ship to individual houses, the individual parts, like, like anything unlike what it was there about 10 years back. So yes, I would say that, if from a manufacturing and sourcing perspective, if we are able to scale, especially the 3D printing aspects, I think we will be able to solve this problem.
We have time for just one more question. So, okay, I think he had raised his hand earlier.
Hi. I'm from Magic Wand Media.
Okay.
This is for Modern Manufacturing India magazine.
Can you hold your mic a little closer?
Yeah. My name is Murali Sundaram. We have been speaking about additive manufacturing from the year probably 2017, 2018. How do you think, there are a lot of people, particularly in SME and MSME segment, not even aware of what additive manufacturing is. How far Siemens is reaching out to these SMEs and MSMEs to educate about additive manufacturing?
Yes, maybe I'm not the expert here in terms of what Siemens is exactly doing with some of the customers, but I have some hints. Yes, we have a motion control division, Siemens Limited, out here. We don't manufacture the additive manufacturing machines, but however, our controllers, our CNC controllers are definitely upgraded to work with the additive manufacturing machines, and we are working very closely with the machine manufacturers, right, to see how our controllers are able to fit there better. And as and when, the demand for this individualized and the personalized manufacturing goes up, as and when, the cost of the 3D printing complete mechanism goes up, that's when the sales also go up. But today, yes, from a controller perspective, Siemens manufactures this numeric range of, CNC controllers, which fit, which are able to work with the additive manufacturing machines and able to do. But MSMEs, yes, not just the additive manufacturing part, but we are working very closely with the MSMEs, in this country on various aspects. If I just want to cite, one example, right in Bangalore, there is a central, the Machine Tool Institute, CMTA, you might have, heard of. So we are actually working with them on a performance digital twin, where the remaining life of the ball screws and the spindles are being calculated through accelerated aging virtually, right, in this digital twin. You have to discard some of these parts right in time, right? You don't want to discard them early because you are wasting material. You don't want to discard them a little too late because it can lead to unplanned events. OPC UA integration, which is OPC UA is the mandated protocol for Industry 4.0. We have integrated into many of our systems. I was a part, and Siemens also is a part of this education. We are helping out many of our MSMEs also to integrate well and use the latest OPC UA technology from a communication perspective. That's another example that I can cite.
Okay.
So
thanks, Sanjay.
Thank you.
This, as I said, this is such a vast topic. Multiple questions can come in, and Siemens is playing a very pivotal role in shaping the future with digital technology, and to that, thanks for sharing the views.
Thank you so much.
I'll also take this opportunity to just briefly introduce Sanjay. Sanjay has a BE from Bangalore University. He has a vast experience in large-scale global software development across sectors like telecom, healthcare, and industry. In his 30-plus years of experience, he has handled diverse responsibilities from being a system and solution architect to product solution security, program portfolio management, and currently he leads a team of 1,000-plus software and hardware experts at the process automation and motion control division of Siemens Advanta. And despite his being a business head, he is very keen in technical topics, and he engages to drive the architecture, and he's very hands-on, and you could see that in the way he has answered some of the questions. And he's available, so for your questions, I think you can always reach out to him during the lunch break.
And so, we also have a booth,
yeah,
the Siemens booth, where we can do a deep dive on smart manufacturing, and it could be some additive manufacturing questions or surrounding digital twins, and there are a couple of other things also. But most welcome to the booth. We can have a more detailed, specific one-on-one conversations also. Okay, so thank you so much for your patient listening. I hope you had some takeaways.